Hey everyone, this is a video I promised that I would do about on the study guide to prepare us for tomorrow's exam. So sorry that this video is a little bit late, but hopefully you have time to watch it before your exam. I plan on talking about everything that we are doing on the exam tomorrow that you will be tested on. Um, so if something doesn't feel relevant to you, you've already understand that, go ahead, feel free to skip around through this video to make sure you're hitting the most important parts because it might be sort of long. On tomorrow's test, you will be tested on some definitions, and I want to talk about what some of those things are. The first being uniform and non-uniform probability. So uniform, and this is an example of uniform right here, is when all of the probabilities are equally likely. All the probabilities are equally likely. And that basically means, like, look at this spinner right here. We have 4 equal sections, right? Each of these sections would have a 25% likelihood of our spinner landing on it, green, blue, red, and pink. All of our probabilities are equal to about 1/4 or 25%. So we would say this is an example of a uniform probability because the probabilities are equally likely. Over here, this is our example of non-uniform. Non-uniform. Because clearly, if we were to spin the spinner, the probability that we land on this green area is much larger than this blue area. In fact, this might be like 75%, and this is like 25%. So, you guessed it, non-uniform probabilities. The probabilities, I'm going to abbreviate it, that the probabilities are not equally likely. Are not equally likely. And as long as you can remember this, uniform, equally likely, non-uniform, not equally likely, you should be in fine shape for those definitions. The other thing I want to talk about is the observed relative frequency, or ORF, versus the theoretical probability. So I got a couple questions on this. The observed relative frequency is what we observe in an experiment, while the theoretical probability is what we expect given the ratio of successful outcomes versus total outcomes. So I wrote this right here. I flipped a coin 10 times and got heads 3 times. I'm going to switch to red. So out of the 10 times, I got heads 3 times. Therefore, the observed relative frequency, or ORF, of heads would be equal to 3 out of 10, because I got heads 3 times out of a total of 10 times. So I could say it's 30%. But we know that if you flip a coin, that you have a 50% likelihood of landing on heads. The reason we know that is because we're talking about the theoretical probability. So for the theoretical probability, this is the number of successful outcomes out of the number of possible outcomes, or total outcomes. Right? We know that for this, that out of our total outcomes, right, there are 2 total outcomes when you flip a coin, heads and tails. And out of that, we only care about one of those. One. We care about heads, right? Heads out of tails. Heads out of heads and tails, right? Because a success would be getting a heads, and there are 2 possible outcomes. So this would be 50%. Right? And we can see this discrepancy between these 2 numbers right here, 50% and 30%. It's because this one is based on an experiment. So that's an important thing to know. Ooh, that's terrible. Experiment. Whenever we're talking about the ORF, we're talking about an experiment. So observed relative frequency is something that's observed through either a survey or an experiment, or something that requires trials, where the theoretical probability is calculated without actually doing an experiment, right? This is maybe what you'd expect, and this is what you observe. what you observe. Okay, cool. On that same topic, these are the definitions that we need to know, so make sure you understand that. On that same topic of observed relative frequency versus theoretical probability, we're also going to be talking about convergence, or as we increase the number of trials, we know that the observed relative frequency gets closer to the theoretical probability. And some of you might remember this spinner example that we did in class one day. I've redone this so it's 50% blue and 50% yellow, and I'm actually going to call this heads and tails, just so that we can really understand this. This experimental probability is the same thing as observed relative frequency, so don't worry too much about it. Experimental probability, it's like, or percentage experimental, is what we're getting from looking at our number of trials. So I'm going to do this spin 10 times, and this theoretical percentage, right, this is our theoretical probability. So it makes sense that we're saying 50% for blue or heads, 50% for yellow or tails, right, because 50% of the area of this circle is blue and 50% of the area of this circle is yellow. So this is what we'd expect, right? We'd expect if we spin the spinner that 50% of the time we're going to get blue, and then 50% of the time we're going to get yellow. So let's spin it 10 times and see what happens. I'm going to skip. All right, so I spun it 10 times, and I landed on blue 4 times and yellow 6 times. So if I were to say, what is the observed relative frequency of blue? Well, I'd say, well, that's 4 out of 10. Right? 4 out of the total of 10, or 40%. Similarly, the observed relative frequency of yellow or tails would be 6 out of 10, or 60%. But the theoretical probability didn't change at all, right? It stayed 50% the whole time. And what we're going to notice is we've only done 10 trials, and we could see that, yeah, while this isn't that far from 50%, it could be closer. So I'm going to up this to, I'm actually going to do 300 spins, and what we should notice is that the observed relative frequency gets closer to this theoretical probability. So let's skip that. Awesome. So I did 300 spins. Wow, that actually got really close. We landed on blue 161 times out of the 310, which comes out to 51.9%. And we landed on yellow 149 times out of 310, which comes out to 48.1, right? And these are getting super close to 50%. And I can up this to do even more spins. Oh, so after 810 spins, it looks like we landed on blue 407 times, or 50.2% of the time, and yellow 49.8% of the time. Now these are super close to our theoretical probability. So what you should notice is that not only are they getting closer, but they're converging. And I'm gonna write this, oh man, let me write this word. Let me undo this real quick. Erase this all. Okay. Maybe I'll cut this out when I actually post this video. All right, so we notice that the ORF is converging. And I swear if you use this word converging on the test, I would be super impressed. Converging to the theoretical probability. Theoretical probability. Converging, it just means getting closer to. It's like a math term for getting closer to. So the ORF is converging or getting closer to the theoretical probability as the number of trials increase. As the number of trials increase. And that's going to be super important for your test. You're going to have a question directly related to this. So make sure that you understand this. The website I used for the spinner, I just Googled Illuminations adjustable spinner, and this came up if this is something you want to play around with on your